Hey everyone, this video is on graphing lines using intercepts. We'll be talking about x and y intercepts and dealing with lines in standard form. So it says right here to recall that the graph of a linear relation can be modeled using this equation right here. Just a reminder, if you are familiar with y equals mx plus b, you can also use that if you prefer. It doesn't really matter. But also just a reminder that a is the slope, and the slope tells us the rise over the run. And then k represents your initial value, and graphically it is represented as the y-intercept. And your slope is also your rate of change, okay? But the problem is that sometimes we won't be given the equation in slope y-intercept form. So sometimes they'll be given in standard form, which is ax plus by plus c. And then also you might see it in any variation of these forms as well. So when we want to graph an equation that's not given in slope-intercept form, we have two options. So here are our two options. We could either rearrange the equation so that it's in slope y-intercept form. Essentially what that means is you just really need to isolate y. If you notice in slope y-intercept, the y is fully alone. So we need to rearrange it so that the y is completely alone. Or we can use x and y intercepts to graph the relation. But before we do that, we have to identify what x and y intercepts are to begin with. Okay, so on Desmos, I've graphed out a bunch of different lines in all different kinds of forms. So we've got like slope-intercept form, we have standard form. This is a little variation on standard form. Slope-intercept form, we've got all different kinds of equations. But I want to just look and see what our x and our y-intercepts are. So our y-intercept is where a graph crosses the y-axis. We already know that that's the k value. And the y-intercept here is 0, -6. And if you look at this right here, our y-intercept here is 0, 5. And if you notice at this one right here, our y-intercept is 0, 1.4. It's not a pretty y-intercept, but it's still a y-intercept. And this one right here, y equals 6, our y-intercept is 0, 6. And x equals 10, there is no y-intercept. And it all comes down to what all of these y-intercepts have in common. And they all have a 0 in the x, because in order for it to cross through the y-axis, x has to be 0, okay? And that's why x equals 10 doesn't have a y-intercept, because x will always be 10. It will never be 0, right? All right, now let's take a look at what's in common with our x-intercept. So for the line y equals 2x minus 6, the x-intercept is at 3, 0. In this next one, the x-intercept is super close, and it's at 3 1/3, 0. Our next one's x-intercept is at -7, 0. Y equals 6 doesn't have an x-intercept, and we'll talk about y in a minute. And then x equals 10 has its x-intercept at 10, 0. So if you notice, what's in common with all of these x-intercepts is that y is 0, which is, again, that should make sense to you just like for the y-intercept, because in order for it to cross the x-axis, y has to be 0. And that's why y equals 6 has no x-intercept, because y will always be 6. So what does that tell us? It tells us that the x-intercept will happen when y equals 0. And it also tells us that the y-intercept will happen when x is 0. All right, so let's use that information to graph out our line. So it says graph each relation using both options. So for starters, let's find our x-intercept. So if our x-intercept happens when y equals 0, what I would do is I would copy down my equation, x plus y equals 3, and then I would sub in y equals 0, because by subbing in y equals 0, I can now actually figure out what my x-intercept is. So here I would say x plus 0 equals 3, and x plus 0 is just x, so x equals 3. So that means that my x-intercept would be 3, 0. Again, the y value 0 is because in an x-intercept, the y value is 0, right? So I'll put 3, 0, that's my x-intercept. Now to find my y-intercept will always happen when x is 0. So I will write down the equation, And this time I'm going to sub in x equals 0. So here I'm going to say 0 plus y. And my bad, I'm sorry, I meant to say equals 3 here. That's a mistake. Equals 3. So then 0 plus y is just simply y. So y equals 3. So my y-intercept would be 0, 3. So then all I have to do right here is plot out the point 0, 3, and then I can just connect the dots. That would be my line. And make sure that that line goes all the way through your graph paper. And also don't forget to write the equation on the line. So x plus y equals 3. But I also have the option to, that was option number 2 right here that we just did. I also have the option to rearrange the equation so that it's in slope-intercept form. So I can just isolate the y. So right here, if I have x plus y equals 3, I can subtract the x from both sides and I would get y equals 3 minus x. Or I could also write this as y equals negative x plus 3. Both are perfectly acceptable, which means that my slope right here would be whatever my coefficient is in front of this x. It's the a value, right? Because remember, it's y equals ax plus k, and a is your slope, and k is your initial value. So here your a would be negative 1, but remember we have to write it as a fraction. And then our k value would be this constant that's right here. So our k value would be 3, which should make sense to you because k stands for the y-intercept, and we already figured out that the y-intercept was 3. So let's take a look at this line right here. So if the initial value is 3, I'd put a dot at 3, and then the slope is negative 1 over 1. So I'd go down 1 to the right 1, put a dot, down 1 to the right 1, put a dot, down 1 to the right 1, put a dot. It's the exact same line. So here, this is how it shows you that you actually have 2 options to graph out. Okay. In the next example, I actually want to isolate y in this next example first. So if I write down the equation, it's x plus 2y minus 4 equals 0. So I'm going to subtract the x, and I'm also going to add the 4 all in the same step just to make my life easier. So that's gone and that's gone, right? So I end up getting 2y equals 0 minus x is negative x, and then I'm just going to have a plus 4. Now pay very close attention to this next piece right here. When I divide by 2, we've learned that we could write it like this, where I show division by 2 on both sides. But because we have y equals ax plus k is our slope-intercept form, I strongly suggest that you actually go through and divide every single term by 2, so it's still in this format. We still have an ax, we still have a k. So now be extra careful about this, because right here, this would be negative 1/2 x. Or we could leave it as negative x over 2. That's fine, as long as you understand that that's negative 1 over 2, which means that our slope is negative 1/2, and then just divide that and I would get 2. One common mistake is that people will say it's negative 2x, which is not true, okay? So here I know my slope is this a value right here, so slope would be negative 1/2, and we know that the initial value, the k, would have to be 2. So how do we graph this out? I would start this at 2, and then remember slope is rise over run. So make the 1 negative, so you would go down by 1, make the 2 positive, and you would run to the right by 2. Okay, so that's what I did right here. I went down by 1, and then I just went right by 2. And then from here again, I'm going to go down by 1, and I go right by 2, and I just keep going right here. And I can also work backwards if I like. And this is my line. Now I would also show you how to do this using the x-intercept and the y-intercept for 2 reasons. The whole point of this video is to learn both ways, but also this is a good way to verify to make sure that you did everything right. So if I want to find my x-intercept, remember your x-intercept is always going to happen when y equals 0. So here I'm going to sub in y equals 0. So this is going to look as follows. x plus 2 times 0 minus 4 equals 0. And then 2 times 0 is 0. So I end up getting x plus 0 minus 4 equals 0. And then these go together, so you end up getting x minus 4 equals 0, which means you add the 4 to both sides, you get x equals 4. So that means that your x-intercept would be at 4, 0. Just a quick note, if you get to this step right here and you just want to cross that out and go straight to this line, that is totally fine. I showed it step by step so you can kind of understand what's going on. But again, if you understand how to get straight to that line, you're good to go. Okay, so we know that our x-intercept should be at 4, 0, and take a look at that. On our line, our x-intercept is at 4, 0. And then our y-intercept would have to be when x is 0. So here, I'm going to sub in 0 for x. So this is going to say 0 plus 2y minus 4 equals 0. I don't even need to rewrite that 0 down. So I just plain and simply get 2y minus 4 equals 0. Add the 4 to both sides, so I get 2y equals 4. I'm not showing the little steps anymore. So we end up getting y equals 2. If you still like to show the steps to help you understand what's going on, feel free to do that though. And if you look right here, my y-intercept really is at 0, 2. So I did this correctly. All right, in the next example right here, let's go ahead and find our x-intercept first. So our x-intercept will always happen when y equals 0. So I'll write down my equation. So I'm going to sub in y equals 0. So I'm going to say 6x minus 3 times 0 equals 15. So then 3 times 0 is 0. So I get 6x plus 0 minus 0. It doesn't really matter. 6x plus 0 is just simply 6x. Divide both sides by 6. I get 15 over 6. 15 over 6 can be reduced. They both have a common factor of 3. So I get 5 over 2. So here our x-intercept is not as pretty, right? So how do I graph out this point? Well, you should just figure out what 5 over 2 is. So if 5 over 2 is pretty much 2.5, so what I'm going to do here is I'm going to go to 2, I'm going to go to 3, and I'm going to go halfway between those 2 points. And so this would be at 2.5 right here. Okay. Another quick note, if you want to go straight from this line to this line, feel free to do so. No worries at all. Okay, so now let's go ahead and find our y-intercept. So our y-intercept is going to happen when x is 0. So I'm going to say 6 times 0 minus 3y equals 15. And then 6 times 0 is 0. And then here, be extra careful. This 0 minus 3y ends up being negative 3y. So don't forget that that is a negative value. Divide both sides by negative 3. I get y equals negative 5. So my y-intercept would be 0, negative 5. So when I take a look at this right here, I can see that that is where my y-intercept would be. So I can go ahead and connect those dots. Make sure your line goes all the way through your graph, and make sure to label your equation on the line. And now I say that, I just realized I did not label my equation on this line right here. So let's actually talk about this, because what I actually did was I isolated y. So probably I would be more likely to write y equals negative 1/2 x plus 2. However, if you want to write the original equation, x plus 2y equals negative 4, it doesn't matter because they're the exact same line. They're just rewritten in a different way. So since they're the exact same line, you can use either equation to write. All right, let's make sure we can identify the slope and the initial value as well. So I'm going to isolate y, and I'm actually going to show you 2 different ways that you can do this, and I want you to pay very close attention to both ways. So one way I could do this is by subtracting 6x from both sides. In doing that, I get negative 3y equals 15 minus 6x. It is very common for people to forget about bringing that negative down. Do not make that mistake. okay? And then because it is negative 3y, I have to divide everything through by negative 3. So I end up getting y equals negative 5. And then these double negatives would turn into a positive 2x right here. So that means that my slope is the a value. This is out of order, but the a value is still going to be 2. So this is 2 over 1. And the initial value would be negative 5. It's the constant right here. So I'd started at negative 5, go up 2 and over 1, up 2 and over 1, up 2 and over 1. And that makes the x-intercept make sense because it's halfway through your rise and your run. Okay? But I want to show you another way to do this that will help you. I personally think it's easier. It looks like it's more steps, but generally it's easier. So instead of subtracting 6x from both sides, I'm actually going to add 3y to both sides. Now in doing that, that doesn't help me to get the y alone quite yet. But now if you notice, my y is positive, so I don't have to worry about forgetting to bring this negative down, dividing everything through by a negative. It's a positive 3y, which is just generally so much easier. So now that I've done that, I can subtract 15 from both sides. So I end up getting 6x minus 15 equals 3y. And then lastly, I just have to divide everything through by 3. 6x divided by 3 is 2x. 15 divided by 3 is negative 5. This ends up becoming a y. And so we still can see that our slope is 2 over 1 and our y-intercept is negative 5. Isn't it amazing how everything just kind of lines up? Okay, so in question D, where it says y equals 2, I'm going to kind of use a mix of both methods. We're going to find the y-intercept. So we know that our y-intercept is going to be 0, 2, because that always happens when x equals 0, but there is no x, so y will always be 2. But I'm also going to put this in slope-intercept form. So y equals ax plus k. But there's nothing added on here in front of this 2. So that means that this is essentially y equals 0x plus 2, where 0 is the slope. And remember, if 0 is the slope, then it's going to look horizontal. So all I have to do is graph out a horizontal line with a y-intercept of 2, write the equation on the line, and then I'm done. That's all I have to do. Okay, and then in question E, it says x equals negative 6. Well, in this question right here, we know that our x-intercept would be negative 6, 0. So our x-intercept would be negative 6, 0. And we would do y equals ax plus k again, but the k value is the y-intercept. And if you look right here, y isn't equal to anything, so there is no y-intercept. And don't forget, when it's x equals a number, it's always going to be a vertical line, which means that the slope is undefined. There is no slope, so we can't use y equals ax plus k. But we do know that we have an x-intercept of negative 6. And we also know that our line is a vertical line. So I'm just going to draw a vertical line through x equals negative 6. And I am done. And that's it for this video. If you have any questions, let us know. Otherwise, we will see you in class. See ya. Bye.